Hi, welcome back to our design of our RISC-V CPU. This time we'll add support for the JAL instruction. JAL instruction stands for jump and link and is the only instruction that we have in the J format. J format has a 20-bit wide immediate and then field for a destination register and the opcode. It does two updates to the state of the processor. It saves the value of PC plus 4 in the destination register, so we have the return address, and sets the new value of a program counter to be equal to the current value of a program counter plus the offset, and the offset is set by the immediate. So it performs a program counter relative jump, where we can jump anywhere that these 20 bits of the immediate allow us to do. So the target will be anywhere within plus minus 2 to the 19 locations, and these locations are set to be 2 bytes apart to support the compressed instruction set, which means that we can jump anywhere from minus 2 to the 18th to plus 2 to the 18th 32-bit words in our code. We have all the hardware that we need to implement jump and link. We just need to have a way to generate a J-type immediate. So if you look at the data path, we'll see that we really actually have everything we need. The only update is immediate generation has to become of J-type. And J-type is similar to a B-type immediate. We just need to add a few more multiplexers to multiplex in most significant bits, the top 8 significant bits. So when we look at the data path, we have the two mechanisms that we are borrowing from JAL R and branch to implement JAL. So the first thing that we need to do, we need to save the value of PC plus 4 in the destination register RD. We do that by using the same mechanism that we have added for JAL R. We send the PC plus 4 value to the write back select register. Write back select is set to have the value of 2, and that enables us to write into the destination register RD. The second mechanism we are borrowing from the branch. What we need to do, we need to make the ALU add the value of PC at its input A with the new immediate value and send that result back to the program counter. We are going to set the PC select signal to be always taken, and that's it. Let's light up the JAL data path. We start with the instruction fetch and we proceed to the decode. So a few things that I would like to highlight here. We are sending the PC to the A select multiplexer, and we are sending the PC plus 4 to the write back select. When we decode the instruction, we set the control bits appropriately. Simultaneously, that will generate the immediate that is of a J type, and then we have the right operands in front of the ALU. The ALU multiplexer inputs are set to pick the program counter and the immediate, and the output of the ALU will be sent back to the PC cell multiplexer. PC cell multiplexer also has a PC plus 4, but it will not take it because PC cell signal is always set to be taken. Finally, we just use the write back select multiplexer to pick PC plus 4 to be written back in the destination register RD. On the next clock tick, the destination register and the program counter are updated to the new values. And that is it. That is what JAL does. See you in a bit with the long immediates.